Assalamu alaikum. Today we will continue with chapter 5 about forces. Before we start, please prepare your stuff and follow these instructions. At the end of this video, you will be able to recognize some of the forces that were mentioned before. We're gonna name them and specify or indicate some of their characteristics. In the previous videos, we identified some of the forces. Let's review them. The first one is the gravitational force or the weight. This force occurs due to the attraction of Earth, of the gravity of Earth. It is a force acting from a distance. The second one is the tension force. This force occurs in the presence of a spring, string, or a wire. It is a force that acts upon contact. The object should be in contact with the wire or spring or string. The third one is the normal reaction of a support. It occurs when we have a support, like here we have a table. It is a contact force, and the line of action of this force is always perpendicular to the support. The fourth one is the muscular force. It occurs when we push or pull an object using our muscles, the muscles of hands or the muscles of the legs. Let's learn about new forces. It's experiment time. Now please pause the video to prepare the following materials if you have them. You need a ball, a table, a ruler, a piece of paper, a feather or a wool cloth, a magnet, a metallic pen. Let's do an experiment. Experiment 1. Materials needed: some metallic pens and a magnet. Procedure: approach, which means put it close, the magnet slowly toward the pens. Let's see how. Put the magnet close to the pens. Let's try to solve the questions. Is there a force exerted by the magnets on the pens? Justify. What do you think? Of course we have, since the magnet attracts the pens toward it. Indicate the direction of this force. What do you think the direction of this force? Here in this case, the direction of the pens are upward. In other words, the pens are directed toward the magnet. Choose the correct answer. Of course, you should choose the most reasonable one. The force exerted by the magnet on the pens is called muscular force, tension, or magnetic force. What do you think? For sure it's magnetic force, since we have a magnet. The magnet can attract the metallic pins, even though a distance separates them. The force exerted by the magnet on the pins acts at a distance or upon contact. What do you think? First of all, we gave you a hint in the given. The magnet attracts the metallic pins from a distance. And as we see here, we have a distance between the pins and the magnet. The magnet and the pins are at a distance. So, which one is correct? Of course, at a distance. This force, which is the magnetic one, acts at a distance. Let's identify. Magnetic force symbolized with capital F with a small m. Of course, we have a vector above it. The magnetic force is the force exerted by a magnet on a metallic object. Here we have the magnet trying to attract the metallic object. Characteristics of this force. Of course, first we have the point of application. It is a force that acts from a distance, so the point of application is the center of gravity. Here, the center of gravity is given. Why? Because the pen has an irregular shape. The line of action is the line joining the center of the magnet and the object. In this case, it is oblique. Let's see it. The direction is always toward the magnet. In this case, it is downward to the left. Experiment 2. Materials needed: a piece of paper, wool cloth, and a plastic ruler. Approach the plastic ruler toward the piece of paper. Let's try solving the questions. Is there any force exerted by the plastic ruler on the piece of paper? Try it. Do we have any force exerted by them? Of course not. Wrap the plastic ruler with the wool cloth, then approach it toward the piece of paper. Let's watch the video. Try to do this experiment. Hope you enjoyed. Try it, then continue solving the questions. The plastic ruler is now electrically charged by rubbing. Is there a force exerted by the charged plastic ruler on the piece of papers? What do you think? Of course, since the pieces of paper are attracted to the charged plastic ruler. Choose the correct answer. Of course, we should choose the most reasonable one. The force exerted by the charged ruler on the piece of paper is called the magnetic force, the electric force, or the weight. What do you think? Of course, it's the electric force. Why? Because the plastic ruler, is electrically charged. This force is a force acting at a distance or a contact force. Look, observe here. Is the plastic ruler directly in contact with the papers so that it attracts them, or at a distance? It was at a distance. Let's identify electric force. It's symbolized with capital F with a small e. Above it a vector. The electric force is the attractive, which means make them close, or repulsive, make them far, forces between two objects where at least one of them is charged. The characteristics of this force: of course, the point of application is the center of gravity. Why? Because this force acts from a distance. The line of action according to this case is vertical. The direction here is upward toward the charged ruler. So the line of action and the direction are according to the case we have. Now, experiment 3. Materials. You need a ball, a table, a piece of wool cloth. Procedure. Roll the ball on the table and observe its motion. Let's see how. By our hand, we roll the ball on the table. Cover the table with a piece of wool cloth. And again, roll the ball on it and observe what will happen. This is a wool cloth. What did you notice? What happened? Let's solve the question that follow. The wool cloth is considered as a rough surface, a support. Is there a force exerted by the wool cloth, the rough surface, on the ball? What do you think? Of course, yes. There was a force. What is the effect of this force? What did you notice between the motion of the first ball and the motion of the second one? The wool cloth slows down the ball's speed. The first one was fast, while the second was slow. The force exerted by the rough support on the ball during its motion is called friction force. Choose the correct answer. The force of friction is a force acting at a distance or a contact force. What do you think? Of course, a contact force since the ball is in contact with the rough surface. To know more about friction, let's watch a video in which a boy has a problem due to friction force. How is he going to solve this problem? Let's see.
Friction. Why is it difficult to pull a boat on the beach than on the sea? Hey, you will find it difficult to pull the boat on the beach. Pull it on the sea. There it will be quite easy.
Indeed, why not?
Fine, don't listen.
Oh, I'm so tired.
At least now try to pull the boat on the sea. It is quite easy. Right?
Yippee!
Do you know why? This is because of friction. Friction is the force which opposes the motion of an object. It always acts in the direction opposite to the direction of motion. The amount of friction depends upon the texture of an object and the surface on which it is being moved. Rough textures or surfaces offer greater friction as compared to smooth textures or surfaces.
Arg! Do you want to say that my brand new boat has a rough texture?
No! Even though the texture of the boat is almost smooth, the small particles of sand present on beach form a rough surface. Hence, when we pull the boat on beach, the sand particles offer greater friction and oppose the motion of the boat, thus making it difficult to move the boat on the beach. However, the sea being a liquid forms a smooth surface. Hence, when we pull the boat on sea, it offers less friction, thus making it comparatively less difficult to pull the boat on sea.
Let's identify friction force, symbolized with a small f above it a vector. Friction is the force exerted by surfaces on moving objects. Friction opposes the direction of motion of the object. If you notice here, the man is trying to push the closet. The direction of the motion is toward the right. The force of friction works opposite to the direction of the motion. Friction always slows a moving object down and make the task hard. Do you see the man? He's tired while pushing the closet. Since the friction opposes his movement, friction produces heat and may also produce an annoying sound. Let's identify its characteristics. The characteristics of friction. First of all, it's the point of application. Since this force is a contact force, so the point of application is the point of contact between the object and the surface. The point of application is the point of contact between the object that we have and the surface. The line of action is along the surface. Here the line of action is horizontal, while here the line of action is oblique. The direction opposite to the direction of movement. Here the direction of motion is toward the right, so the friction will act opposite to this direction, so the friction will be to the left. Here the direction of the man is upward to the right, while the friction will be downward to the left. Always the direction of the friction opposite to the direction of motion. What are the advantages of friction? We need the friction to walk properly, to write, and to erase. Friction enables us to walk properly and prevent us from sliding. Also, we can write using a pencil due to the friction force between the pen and the paper. We can also erase what we have written due to the friction force between the eraser and the paper. For example, writing with a pencil requires friction. You could not hold a pencil in your hand without friction. It would slip out when you try to hold it to write. More advantages of friction. When holding a glass cup, friction is involved. How? Our hand seems smooth, but the fingerprints make the skin rough enough to hold firmly the glass due to the frictional force between the surface of our hand and the surface of the glass. When you try holding a glass with oil or soap on your hand, it tends to slip. The friction between the surface of the hand and the surface of the glass decreases in the case, causing the slipping of the glass. In snowy seasons, we increase the force of friction by covering the tires with iron strings to allow the car to move on snow. Cars will slip and an accident may happen, لا سمح الله. So friction here is beneficial to avoid an accident. Air resistance. Air resistance is a kind of friction. Air resistance is a friction between air particles and a falling object. Like friction, air resistance acts in opposite direction to the movement of the object. So, air resistance always tries to slow down the moving object. Air resistance is used by parachutes to slow down their fall. How? The open parachute make a lot of air resistance. This slows the parachute down, and the parachutist drops gently to the ground. If you noticed here, we have air resistance which slows down the movement of the falling object. It acts opposite to the moving object. The direction of the moving object is downward, while the air resistance works in opposite direction, so it works upward. Let's practice. Please open your booklet on worksheet 7. If we go back to figure 1 in worksheet 7, what new forces are you going to add in the table? What is the force that is exerted on the falling box? What do you think? Since this box is falling in air, so we have air resistance. Let's write its characteristics and indicate its type. First of all, air resistance is a force that acts upon contact. It's a contact force. So, the point of application of this force is the point of contact between the air and the box. We're gonna name it O. The line of action of this force is vertical, and the direction opposes the direction of the motion of the object. Since the object is falling down, so the direction of air resistance is upward. Let's see. The line of action is vertical, the direction is upward. Let's represent it. Vertically upward. The magnitude is represented with R and the SI unit is Newton. The same for figure 6 in worksheet 7. What new forces are you going to add in the table? What is the force exerted on the box during its motion other than the weight, the normal reaction of support, and the muscular force? What do you think? Of course, it is the friction force. The friction force is a contact force. What its characteristics? Let's list them. First of all, the point of application. The point of application is the point of contact between the object and the surface. Why? Because it's a contact force. Let's represent it on the figure. We can take any point in contact between the box and the surface. We're gonna name it S. Let's see the direction of motion. The direction of motion of the box is toward the right. So, the line of action of this force will be along the surface and the direction will be opposite to the direction of motion. If the direction of motion to the right, so the direction of the friction force is to the left. Let's write them. The line of action is horizontal along the surface and the direction is toward the left because it's opposite to the motion of the box. The magnitude is represented with a small f, and of course the SI unit is in Newton. Now please pause the video and name the forces acting on the object underlined in the given. List the type of each force and list its characteristics. Let's continue. Point G is the center of gravity of the nail. It's given since the nail is irregular in shape. The nail is attracted by the magnet. Let's list the forces acting on the nail, starting with the weight. Of course, the first force we should talk about is the weight. The weight acts from a distance. The point of application is the center of gravity of the nail, and it's given because the nail is irregular in shape. The line of action vertical and the direction is downward. Let's write them. Point of application, center of gravity, line of action vertical and directed downward. The second force acting on the nail is the tension. How did we know? Because here we have a wire. So the tension force, what is the type of this force? It is a contact force. Since it's a contact force, so the point of contact between the wire and the nail is the point of application. The line of action and the direction are along the wire. So here the line of action is oblique and the direction is upward to the left. Let's see how. Let's write them. The point of application is the point of contact between the nail and the wire. The line of action is oblique. The direction is upward to the left. The third one is, of course, the magnetic. Since we have magnet, magnetic force acts from distance. The point of application of this force is, of course, the center of gravity. All forces that act from a distance, their point of application is always the center of gravity. The line of action and the direction are toward the magnet, so the line of action is here horizontal, will be, and directed to the right, toward the magnet. Let's write them. The point of application is the center of gravity. The line of action is horizontal and directed to the right. It is represented, as we said before, with capital F and small m. The SI unit, of course, in Newton. Let's continue. Same questions for figure 5. We should name the forces acting on the ball covered with aluminium foil. We should indicate the type of each force and list the characteristics. Please pause the video and try to solve it. Let's continue. A plastic rubbed rod is put near a ball covered with aluminium foil. What is the first force acting on it? Of course, it is the weight. We always mention the weight. The type of this force is acting from a distance, so of course the point of application of this force is the center of gravity. The center of gravity here is the center of the ball. We're gonna name it G. The line of action is vertical and the direction is downward. Let's write them. Point of application is the center of gravity. The line of action is vertical and directed downward. The second force that we're gonna talk about is the tension, of course, because we have a wire. So this force, as we said before, it's a force that acts upon contact. So the point of application is the point of contact between the ball and the wire. The line of action and the direction are toward the wire. So here the line of action is oblique and the direction is upward to the right. Let's see. Let's represent it and write it. The point of application is the point of contact between the ball and the wire. The line of action is oblique and the direction is upward. The third force here is electric force. Why? Because the plastic rod is charged. This force acts from a distance, so the point of application is the center of gravity, which is here G also. The line of action and the direction are toward the plastic rod. In this case, the line of action is horizontal and directed to the left. Let's represent it and write it. It's a force acting from a distance. The point of application is the center of gravity. The line of action is horizontal and directed to the left. It is represented by a capital F with a small e, and of course the SI unit is Newton. Please complete the tables of figure 1, 3, 5, and 6 of worksheet 7. Also study all the tables of worksheet 7 for a quiz in the next session. Thank you. See you soon.